Whenever you look up at the night sky, you are entirely blind to the present moment. Everything you see has already happened. The universe enforces a strict speed limit. Light travels at roughly 186,000 miles per second. It is incredibly fast, but the physical gaps between stars are so vast that this speed limit creates a lag in reality. Take our own sun. The light it emits takes 8 minutes to cross the void and reach Earth. If the sun were to suddenly explode, we wouldn't know a thing about it for 8 full minutes. We'd just go about our day, bathed in the ghost light of a star that had already torn itself apart. Because of this delay, physical distance and time are locked together. To look deep into space is, quite literally, to look backward in time. To understand these staggering distances, let's shrink the 93 million miles between Earth and Sun down to a football field. A dime on the 0-yard line is our sun. Earth sits right on the 2-yard line. Neptune marks its territory at the opposite 40-yard line. Then there's Voyager 1. Launched in 1977, it has flown outward for over 4 decades, becoming the most distant human-made object in existence. Back on our football field scale, Voyager 1 has completely left the stadium. It's out in the parking lot, drifting roughly 80 yards past the far end zone. We have spent almost 50 years pushing our fastest hardware outward, and humanity's furthest physical reach registers as microscopically small against the isolating scale of our own solar system. Zooming out from that parking lot, the structure of the Milky Way galaxy begins to resolve. Our local neighborhood is suspended inside a swirling collection of anywhere from 100 billion to 400 billion stars. Yet this massive structure is just one island. Our nearest major galactic neighbor, Andromeda, sits 2.5 million light-years away. These two massive islands are inexorably drawn to one another. In roughly 4 billion years, the Milky Way and Andromeda are scheduled to collide. Right now, Andromeda is falling toward us at 250,000 miles per hour. When the two finally meet, the gravitational interaction will throw stars into entirely new orbits and collapse the two spirals into a single, massive elliptical galaxy. Our galaxy is not a static point on a map. It is a violent, kinetic structure, flying through space on a collision course driven relentlessly by gravity. To look past this local violence and test the absolute limits of human visibility, we rely on instruments like the Hubble Space Telescope. For the extreme deep field image, astronomers pointed Hubble at a tiny, seemingly empty, pitch-black speck of the southern sky. They collected photons from that dark target for a total of 22 days. Zooming into the resulting data revealed 5,500 distinct galaxies packed into that microscopic sliver of space. That image captures an extreme look-back time of 13.2 billion years. We're seeing the light of infant galaxies colliding and merging a mere 450 million years after the Big Bang. Over those 13.2 billion years, the universe has continued expanding. The galaxies that emitted that ancient light have been carried outward by the stretching of space itself, pushing the physical edge of our observable sphere to a radius of 46.5 billion light-years in any direction. Because of the speed of light, the deepest image humanity has ever captured functions as a direct visual portal to the fiery origin of reality. This animated pie chart shows the mass-energy composition of the 93 billion light-year observable universe. Every star, planet, galaxy, and speck of dust we've observed constitutes just 4.9% of the cosmos. The remaining majority is invisible. 26.8% is dark matter, and 68.3% is dark energy. We exist as a microscopic anomaly floating in a vast, invisible void. Yet, from our tiny position on the 2-yard line, we have figured out how to capture ancient light and decode the 13.8 billion year history of reality.